Swayam Prabha. Digital India. Educated India.
So, last class I have discussed that how we can determine the portion of load which is transferred to the pile top by using elastic analysis, and then how we can determine the settlement of a single pile, and then we express the settlement of a single pile in terms of shaft load and in terms of tip or base load. So, this is the expression that we derived, that this is the settlement due to the shaft load or in terms of shaft load, and then this is the expression, and in terms of base load this is the expression. And remember that in these two expressions, assume that the load and settlement relationship is linear. Okay. So, now this is the settlement we have written in terms of base and the shaft load. So, now if I draw the settlement in terms of shaft and in terms of base, then we can see that this is the settlement and this is the load. Okay. So, as I mentioned that initially the friction resistance will be mobilized, then the tip resistance will active, and it is not that during the friction resistance mobilization there will be no tip resistance. There will be tip resistance, but that amount will be less compared to the friction resistance. So, I can write that as these equations are developed for considering a linear stress strain relationship. So, we can write that this is the load versus settlement for shaft resistance, that in terms of shaft load this is the load settlement curve. Okay. And this is the load settlement curve for shaft load, because this is linear, and this value is say rho y I. That means, when the shaft resistance will be fully mobilized, so that point the settlement is rho y I or rho y 1. So, this point the shaft resistance is fully mobilized. So, that means, at this point is fully mobilized. Okay, at this point. So, there will be a tip resistance versus settlement plot also. So, that will also continue like this. Okay, that will also continue like this. Okay. So, depending upon if your it is a bearing pile or the friction pile, this curve magnitude will change, but here the tip resistance portion is more compared to the friction resistance. So, that means, when the friction resistance will be fully mobilized, at that point your tip resistance value is very small. Okay. At that point tip resistance value is very small. Okay. So, that means, at this point, when the shaft resistance is fully mobilized, the overall curve will be this total shaft resistance plus the tip resistance. So, overall curve will be something like this at this point. So, this portion will be equal to the tip resistance part. So, I can draw that once the shaft resistance is fully mobilized, then if we increase the settlement, there will be no change in the shaft resistance part. So, we can draw that line like this. Okay. So, this line is basically the shaft load versus settlement plot. Settlement plot, and this curve is base load versus settlement. So, here also once that the base resistance is also fully mobilized and that settlement is this one, say rho u. Now, rho u is where base resistance is fully mobilized. So, after that if you change the settlement, there will be no change in the base resistance. So, that also you can draw like this. Okay. So, now overall curve will be the overall load settlement curve. So, up to this point, so this is this contribution plus the base resistance contribution, this is the overall curve. Then after that point, after this point, there is no contribution due to the shaft resistance, only contribution due to the base resistance. So, at this point the line will be parallel to the base resistance line. Okay, and then it will go straight. So, now there are different point. So, this is one point, this is another point and corresponding to this is another point, and this is also another point. Okay. So, what are those points? So, these points are, this is the ultimate load, because this is overall load settlement curve. Overall load settlement plot. So, this will give you the maximum load, that is P u. Now, this point is given. Okay, so, I have to change because you are here particular this case. This is parallel to this line. Then it will go straight. Here also it will go straight. So, this is point I am removing. So, this is the point corresponding to this point. Okay, so, this is the now this curve is base versus settlement, this is overall load versus settlement. Okay. So, I can write that rho u where the base resistance is fully mobilized. Okay. So, this is equal to the P u and this one is P b u, that means the ultimate base resistance, this one P s u ultimate shaft resistance, and this one P y 1. So, now I am giving one explanation that what are these P values. PSU, you can see this is the ultimate shaft resistance, then PBU is the ultimate base resistance, and PU is the ultimate shaft resistance plus ultimate base resistance, that means the ultimate load of the pile. And this point where the shaft resistance is fully mobilized, in that point the total load, that means the shaft resistance plus the base resistance, will be equal to P y 1, and the corresponding settlement also rho y 1. And here also this is the rho ultimate, which is same for the tip resistance and the ultimate, because as the tip resistance is more and this will mobilize later. So, after that there will be no settlement for the ultimate as well as the tip. So, this is the load settlement curve that we are trying to reach here. So, that means to draw this, ultimately we will draw the overall load settlement curve. So, this, to draw this curve, what are the points we should know, or what are the values we should know. So, to draw this curve, we should know this value, we should know this value, we should know this value, and we should know this value. So, if I know these 4 values and I know the relationship is linear, so then I can perfectly draw this curve, this overall load versus settlement curve, because if I know the settlement at this settlement and this point, so then we can locate this point, and if I know this settlement and this overall, then also I can locate this point. Then what I will do? I will just join these points, one from 0 to this point, another from this point to this point, and then next one will be the straight line. So, then I will get the overall curve. Okay. So, now these things I have to derive, that how I will get these points. So, now I have this settlement. So, next one, that we will get the, assume that pile, or we will assume that pile material is perfectly elastic. Okay. Now, one thing I want to mention, that when you are talking about the settlement, now this settlement is the settlement of the pile material plus settlement of the soil. Now, if the pile is incompressible, then the settlement will be settlement of the soil itself, but if the pile is compressible one, then the settlement of the pile is due to the settlement of the soil and settlement of the pile material itself. So, here when there is a mobilization of the friction, that time also there is some tip resistance. So, that tip resistance will not give any effect on the settlement of the pile material. So, that means, when there is a total tip resistance we have, and that tip resist, due to that tip resistance the settlement of the pile material will occur. Okay. So, that means the settlement of the pile material will occur due to the tip resist, the load which is going to the tip, because the load which is going to the friction part, that will not influence on the settlement of the pile material, because that is going to the friction part. So, that will not create any effect on the settlement of the pile material, but that will create the effect of the settlement of the soil, but the settlement of the pile material, that friction part component will not make any effect. The settlement of the pile material will be due to the load which is transferred to the tip of the pile or the base of the pile. That is one point. another point is that even if that the total base load will not create effect on the settlement of the pile material, because once the settlement of the soil is completed, then the settlement of the pile material will start. Okay? So, remember that once the settlement of the pile material is completed, settlement of the soil is completed, then the settlement of the pile material will start. So, that means settlement of the soil will completed at the end of the fully mobilization of the base settlement or base load. Okay? So, after that the settlement of the pile material will start. So, that means even if the total tip load will not create effect on the pile load settlement, pile material settlement, because the load which is transferred during the fully mobilization of the shaft. So, that will not create any effect on the pile material settlement, because that time soil is settlement is going on. So, as I mentioned, when the soil settlement will stop, then the pile material settlement will or pile settlement will start. So, that means the tip resistance that is during the friction resistant mobilization will not create any effect on the pile material settlement. So, that means we have to subtract that component from the total base load, such that the actual load contribution to the pile material settlement we can determine. Okay. So, now once so that means here I can draw another line, and then we will get the real picture that this is this dotted line actually this dotted line actually the soil versus soil settlement due to the pile base load, this dotted line, and this additional line is the pile material settlement, whence the slip or the total shaft or your soil resistance or soil settlement is over. So, this is the additional settlement. Okay. Settlement of the shaft. Shaft means the pile material. Okay. After the full slip, or you can say the full settlement is over, full soil settlement is over. So, this is the shaft or pile material, or pile I should say. This is the pile settlement or pile material settlement, because pile is incompressible, itself pile settlement, pile material settlement. Okay. This is clear. So, now what we have to subtract that component, which is subtract that tip component, which is which will go to the base during the fully mobilization of the shaft load. So, that means we can write the perfectly elastic, then we can write the additional component of the or additional compression or additional settlement of the shaft or the pile material. So, that will be del rho. So, that will be, as I discussed, that total base load is P b. So, during the fully mobilization of the shaft resistance, the tip load which is transferred to the tip, that we have to subtract during the additional compression of shaft calculation. So, that load is how much? So, you can see that during this total load is P y 1. Okay. So, total load at PSU is equal to P y 1. What does it mean? That total load when the ultimate shaft resistance is PSU, in that case total load is P y 1. So, when the total load at PSU, PSU means ultimate shaft resistance. Okay. So, I can write that during this total load is P y 1. So, how much is transferred to the tip? So, if total load is P, then shaft portion is P into 1 minus beta and base portion is beta into P. So, I can write that at the total load is this one, or I can write that PSU will be equal to PSU, I mean shaft portion will be equal to total load into 1 minus beta. So, total load is P y 1 minus beta. So, the total load P y 1 will be in terms of shaft resistance PSU 1 minus beta divided by 1 minus beta. Now, this is total load, beta portion is transferred to the base. So, I can write thus PB contribution at PSU will be equal to, this is the total load PSU 1 minus beta, then into the beta, that is that beta portion is transferred to the tip. So, I can write this is PSU beta 1 minus beta. So, clear that. So, that means that when the total shaft resistance is fully mobilized, that is the ultimate shaft resistance, at that time total load is, that means shaft resistance plus tip resistance is P y 1. Now, when the total load is P y 1, in that case the shaft resistance will be P y 1 into 1 minus beta. So, the total load I can express in terms of ultimate shaft resistance is P S U divided by 1 minus beta, and that total load contribution from this total load contribution to the base will be the beta times of this total load into beta. Okay. So, that you have to subtract this PB contribution at PSU, we have to subtract, because that will not create any effect on the pile material compression or the additional compression. So, that you have to subtract here. So, this is we have to subtract PSU beta 1 minus beta. So, again we know that is E is equal to P L by A del L. So, del rho will be equal to P by E into L by A. So, this will be P is this one, this is this will be L divided by E p into A p, where E is the elastic modulus of the pile, A p is the area of the pile, L is the length of the pile. Okay. So, the total load, now the total base load versus settlement will be, that means the total settlement will be will be the settlement due to the soil and settlement due to the pile material. So, settlement due to the soil will be I by E s d, and that is P, and P is we will convert it to in terms of base. So, this is the base. Okay. So, this base is P b divided by beta, then plus this settlement, then P b minus P s u beta 1 minus beta into L E p A p. Okay, so, now as I mentioned, we have to determine these 4 quantities. Okay. So, now P y 1 we can now write this way, P y 1 is equal to P s u divided by 1 minus beta. So, beta I have discussed how I will get the beta by elastic analysis. The beta I will get, P s u I will calculate, this is the total sap resistance that I will calculate by using the static equations that I have discussed. So, I will get the P y 1. So, once I get the P y 1, then I will get the rho y 1, which is nothing but I E s into d into P y 1, which is equal to I